In this video, we're going to find the first partial at particular values, and again, using the chain rule. So we've got t as a function of u and v, but u and v are both functions of three variables, p, q, and r. So notice that t has a three partial derivative that we can find with respect to p, with respect to q, and with respect to r. We want to find those when p is 2, q is 1, and r is 4. So one thing we notice here is that first, if I put in 2, 1, and 4 in for p, q, and r, we get u is 4 and v is 8. And that'll help us when we do the partials with respect to u and v here later on. If I do the partial with respect to p, I do the partial with respect to u, and then multiply with the partial of u with respect to p, and then do the same thing for v. When I look back at t, when I do the partial with respect to u, I just have a u on bottom, so I can think of this as 2u plus v to the negative 1. If I differentiate that, I'll get a negative 2u plus v to the negative 2, and then need to multiply by a 2. So that's where this negative v over 2u plus v squared times the 2 is. Differentiate the u with respect to p, we get q root r. That's what this part is here. Now when we do the second term, when I got to do the derivative with respect to v for t, I've got to use a quotient rule. Derivative of the top is 1. Derivative of the bottom is also 1. So I get 1 times the bottom minus v times 1, derivative of the top. Sorry, derivative of the bottom for that one. And then over the bottom squared. Derivative of v with respect to p is root q times r. We plug in 2 for p, 1 for q, 4 for r. That results in plugging in 4 for u and 8 for v. Lots of numbers to plug in, I know. But we're just plugging in 2, 1, 4 for p, q, and r. When we do that, that gives us, again, 4 and 8 for v and u, or 4 and 8 for u and v, I should say. Plug all of those things in, do all the arithmetic, and you get 0. It's a long way to get 0. We do exactly the same thing when we want to do the partial with respect to q. It's just that when we do those second pieces, I have to differentiate with respect to q instead of with respect to p. Notice that the partial of t with respect to u and the partial of t with respect to v does not change. We're doing the chain rule. We're not differentiating the inside yet. So we still have the same derivative here as we had here. And we still have the same derivative here as we had here. That did not change. Now when we differentiate here with respect to q, we just get a p root r. When we differentiate v with respect to q, we get a p is a constant, r is a constant. Derivative of q to the 1/2 is a 1/2 q to the negative 1/2. That's where the 1 over 2q comes from. Again, we're going to plug in 2, 1, and 4 for p, q, and r respectively. When we do that, remember, u is equal to 4 and v is equal to 8. Plug all of those numbers in everywhere that we need to, and simplify the arithmetic, and we get negative 1/8 for the partial with respect to q. Finally, we're ready to do the partial with respect to r. Again, those partials with respect to u and v for t will not change. Derivative with respect to r, for the first one, we get a pq times a 1 over 2 root r. For the second one, we'll just get a p root q. And then again, we want to plug in 2, 1, and 4 for p, q, and r, which results in 4 for u and 8 for v. We plug all of those numbers in, simplify the arithmetic, and we get 1 over 32.